Hey guys, Morgan again. So next we're going to look at this example here, right? So we've got the argument a wedge b tilde a ampersand c, therefore b. Okay, so that's either a or b, not a and c, therefore b. Alright, so let's get started. As I said last time, and as you've seen in the lecture videos, we've got a couple things to do to get started here. I'm going to go ahead and first just list out our basic assumptions. Okay, so we've got two premises in this argument, first premise, second premise, and I'm going to get our proof started by writing out those basic assumptions. So the things that we're starting off assuming to be true. So first one here, a wedge b. And we're assuming this to be true, we're using the rule of assumption. Second basic assumption, tilde a ampersand c. And again, we're assuming this to be true, we're just using the rule of assumption. Okay. So that's our basic premises taken care of. Now what we want to do is go ahead and figure out our overall strategy for this proof, like we did in the last video. So there's two questions that you need to ask yourself, and this is what you were practicing in your assignments last week. Okay, so first question, you want to identify, sorry that marker's too light. Alright, first question, you want to identify what's the conclusion, what kind of a sentence is the conclusion. Okay, so in this case, the conclusion is B. Alright, so our conclusion is an atomic sentence. Second question, we want to figure out how this conclusion is embedded in the premises. We want to try and identify the connection between these two premises here and the conclusion. So as we saw last time, there's three options for this. Okay, there is the possibility that the conclusion B is embedded as a whole, and that would tell us that we would go ahead and use an elimination strategy. There's the possibility that the conclusion B is embedded in parts. And that would tell us that we would be using overall an introduction strategy. And then there's a third option down here, and as I said before, we're going to get to that later on in the week, so don't need to worry about that quite yet. Okay. So again, last time, the last example we looked at, our conclusion was also an atomic sentence. This time we've got B. And of course B, it's an atomic sentence. It doesn't really have any parts, right? We can't break it up. Okay, so what that means is if we're going to find it at all, we're going to find it as a whole. So we look over here in the premises, or down here, and we want to see if we can find this statement here, B, embedded somewhere as a whole. And we do, in fact, right? We see it here in our first premise. See it here in the first premise. So yes, in fact, our conclusion is embedded as a whole. And that tells us we're going to be using some kind of elimination strategy. And now, how do we figure out exactly what kind of elimination? Well, B is embedded in a disjunction, right? B is the right disjunct. So B is the right disjunct of that first premise there. Right disjunct of that first premise. So you want to be able to identify exactly where that conclusion is. It's the right disjunct of the first premise. And now since it's embedded as a whole within a disjunction, what rule do we have that allows us to break apart disjunctions? We have a rule that allows us to pull out the disjunct of a disjunction. And that rule is wedge elimination. Okay, so I said we would be using an elimination strategy overall. Specifically, our strategy is going to be wedge elimination. Okay, so you want to keep this in mind all the while that you're working on this proof. So wedge elimination is the strategy. And now, as I did before, I'm going to make a little roadmap here of how you're going to approach this proof. So, keeping in mind that the overall strategy is wedge elimination. As I said before, what you've essentially just done here is identified the very last step that you're going to take in this proof. Okay, so it's the very last step. It's going to happen down here at the bottom somewhere. So I'm going to go ahead and write this at the bottom of our little roadmap. So we're going to use wedge elimination to give us the atomic statement, our conclusion B. Okay, so we're going to use this rule to give us our conclusion. And now we work backwards. We figure out how we're going to connect this here with the two sentences that were already given to us. So we want to connect the premises with the conclusion. So what you need to ask yourself, okay, thinking about how the rule of wedge elimination works, we need to figure out what we need, what sentences need to be in place in order to carry out this operation here, right? Using wedge elimination to get B on a line by itself. So if you refer to your handout or if you recall the lecture videos, you'll remember that wedge elimination requires two sentences. Okay, so wedge elimination requires two sentences as input. Okay, and then it gives you a single sentence as an output. So if you've got some disjunction, any disjunction, so let's say we've got P wedge Q, and let's say that you want to get Q on a line by itself. That means you need two things. That means you need the actual disjunction, P wedge Q, you need that on a line by itself, and then you're going to need the denial of the other disjunct. So if you've got P wedge Q and you want to conclude that Q is true, you're going to need the denial of P. So you can think of this, for example, the argument either Polly likes apples or Queenie likes pears. Okay, so either Polly likes apples or Queenie likes pears. Polly doesn't like apples, therefore Queenie does like pears. Okay, so that's just a quick example. I think it's a lot of times helpful to try and translate this stuff into